So we'll look at the left and right-hand side separately. And we'll work them down left and right side. So the right side's easier, isn't it? Because there you just have to plug in 4. So I've got to go back up to my function and take a look at it. Sorry. Oh, I should get, there we go. So where do I plug in? If I actually want to plug 4 in, first, second, or third equation there, or first, or second, or third function? Third one, because I've got greater than or equal to, right? So what am I plugging in for x there? 4. Plug 4 in, and what would you get? 8b plus a. Now, the other side of the equation needs to be a limit, which means I need to be approaching 4, but not 4. So which function should I use, first, second, or third? The second one. Because if x is smaller than 4, that means it's close to 4. So I'm going to use that middle one in my limit. So I'm doing limit x approaches 4 of ax squared plus 4b. And go ahead and take that limit. That's a direct substitution. Replace x with 4, and you should get what? 16a plus 4b equals 8b plus a. That's your second equation. What's that? Can do what? Yeah, clean it up. I'm going to clean it up right now. But before I get to that, does everyone see we have 2 equations now? And we have 2 unknowns. 2 equations with 2 unknowns is called the system of linear equations. And so now we have to solve the system of equations. So I'm going to make some room here. And I think I'll write the first equation here. I'm going to write it as a plus 4b equals -3. And the other equation, I'm going to move everything to the left side. So I'm going to subtract an a, which gives me 15a. I'm going to subtract an 8b, which gives me a -4b equals 0. Does everyone agree that's the second equation? Just move everything over to the left side. And I'm going to put that underneath this one. 15a minus 4b equals 0. And I'm going to put a big brace in front of this because in college algebra, that's usually the way we represent systems of equations. And now you have to solve that system. So does anybody know the common 2 methods used for solving systems of equations? That's called elimination. Elimination, and then the other one is called substitution. So it's your choice. I don't care what you do, all right? I just expect that you'd be able to solve this. So I think I'm going to do it by substitution. Actually, I did this earlier, and I did it by elimination, but I'm just going to do it for substitution just for fun. Okay, so what I'm going to do is I'm going to take the first equation. I'm going to solve it for a. Why did I solve it for a? Because it's by itself. It's easy to get a by itself. And now what do I do with that answer? I take into the second equation, I replace a with that. So 15 times -3 minus 4b minus 4b should equal 0. Does everyone see? All I did was I took the a here, replaced it right there. Now, that equation only has one variable in it, doesn't it? So I get, what, -45 minus, what's that, 60b minus 4b equals 0. So -64b equals 45, and b equals -45 over 64. So that was a linear equation. I would expect you could solve that. So I know what B is. What do I do once I know B? I go back up to my equation with A, and I write -3 minus 4 times B, but B was -45 over 64. And I'd multiply that all out and get a common denominator, and you get A is equal to -3 over 16. And that should match up with what we had here. -45 over 64, -3 over 16. Okay? There's no way in the world you would be able to get that, those two numbers, without using the definition of the limit. There's no one in this class going to be able to look at that and go, oh yeah, it's obvious. A is -3 over 16 and B is -45 over 64. Just not going to happen. Okay? So in your work on a test or a quiz or something, you know, I'm going to want to see these two limits set up the way I set them up. You know, show me the breakdown, and then from that create your two equations and then your system and then solve it. All right. All right, the last problem out of this section was this one right here. Show that this, I may have just brought my computer to its knees here. I really don't know what's going on with this computer this semester. It's really lagging on me. Yeah. I don't have several minutes. I know, but I didn't have this problem last semester, so. All right, so if you watch the video, then you know that the last example I did where is it? It's 1.5. Was this one right here. The intermediate value theorem is what I talked about. And we were going to look at this cosine x equals x and use the intermediate value theorem to show that this equation has a solution. So there's the graph of a function. And we're trying to show that there's an x-intercept here. So let me talk about the intermediate value theorem real quick. How many of you saw this on the intermediate value theorem? Make sense or no? Okay. So intermediate value theorem says this. If you've got a continuous function, which is this a continuous function? Okay. If you have a continuous function and you look at it on a closed interval, so you take it and you chop off the ends and you make it just go from one point to another. And you then make sure that the two endpoints are not the same value. So this one, you plug in a number, you get -12. You plug in this one over here, 5, you get 13. So you've got a continuous function on a closed interval, and the two endpoints are not the same. Then the intermediate value theorem says that I can choose any value I want on the y-axis between these two, between 13 and -12. Pick anything I want. Pick anything. Doesn't matter. And what is guaranteed? If I pick a value like 6, what am I guaranteed by the intermediate value theorem? At least one x value will achieve the value of 6. Look, somewhere my graph must be 6. And it comes from an x value of 4.57. This is my There exists, hold on, I got to make sure I got the, there exists the C. Yes, the C is the X value. The D is the Y value. So it's the order of the way you do this. I pick any Y value I want between negative 12 and 13. So let me pick this one right here. By the intermediate value theorem, there's got to be a place, some X value, that would give me that point. When does the intermediate value theorem break down? When the function's not continuous. When you have a jump discontinuity like this, because if I try and pick a value right there, there's no part of my function that ever hits that value. But that function's not continuous, right? Okay. That's what the intermediate value theorem said. Now let's see how we're going to use that to look at this question here. Show me that this equation has a solution, but don't tell me what the solution is. Just tell me it has a solution between 0 and 1. Let me go back to my notes. So I'm going to write down the equation. The equation is cosine x equals x. And I want to look at it on the interval 0, 1. There's some number between 0 and 1 that I should be able to plug in that makes that true. So here's the way we approach it. We first of all take everything to one side of the equation. And then I look at the left side of the equation as a function. I call it f of x. And so what I'm asking for here is to find when f of x is 0. What do those correspond to geometrically? Like, if I ever tell you, hey, set a function equal to 0, what are you actually finding geometrically? When the function is 0 is what on its graph? The x-intercepts, right? This corresponds to the x-intercepts, doesn't it? The x-intercepts of the function. So looking at the function, f of x equals cosine x minus x on the interval 0, 1. Let's look at that function and see if we can figure out if it ever achieves 0. Tell me about this function. Is it continuous or not? Is this function continuous? Can you draw that function without picking up your pencil? Yes? Why? Because 1.5.9, the theorem, 1.5.9, says what? All polynomial functions are continuous. Isn't x by itself right there? Isn't that a polynomial? And what is cosine x? A trig. Doesn't it say all trig functions are continuous? Yes? And look at theorem 1.5.8, the one right above it. Look at number 1. What does it say? F plus g is continuous. So if you take two continuous functions and you add or subtract them, you're still a continuous function. Do y'all see the combination of the two theorems there? So I know right away, right now, f is continuous on 0, 1. In fact, it's continuous everywhere, but I only need it to be continuous on 0, 1. So all I need to do now is plug in 0 into that function and 1 into that function and see what happens. What do you get when you plug 0 in? What's cosine of 0, everyone? 1 minus, plug in 0 for x, you get 1, don't you? What's cosine of 1? Well, you probably need your calculator for that. Minus 1. Make sure you're in radian mode on your calculator when you do cosine of 1.